Okay, so this is Algebra 2, Module 3, Lesson 20, I guess Part 2. And let's go ahead and look at example 1 here, graphing transformation of logarithmic functions. We have the general form of the logarithm here of f of x is equal to k plus a log b x minus h. They're all real numbers. And x minus h has to be greater than 0 because anytime we log something, it has to be greater than 0, correct? You should know that. So given g of x, so we have a parent function basically of a log, and g of x is equal to 3 plus 2 log x minus 2. Describe the graph of g as a transformation of the common log function. All right, so let's look at this. We know, first of all, this 3, whether it's at the end or at the beginning, okay, we're used to seeing it kind of at the end, but here this is going to be simply our translation up. Okay, so I'm just going to pull this over here and say this is a translation, and it's equal to 3 plus, or 3 up. We're going up 3. Okay, so we could even just call this a vertical translation, right? Now, the 2 here tells us what? That's the vertical scale, okay? We're multiplying by the log, so that's a vertical scaling. And since we're not talking about it inside the parentheses with the x, that's the reason why we're referring to it as a vertical scaling of 2, just a regular 2, okay? It's just a 2, vertical scaling of 2. A factor of 2, I guess. Now, this negative 2, let's talk about it. What's happening with this negative 2? And this is where you have to be careful. This is a horizontal translation. We've already had our vertical translation over here, but now we have a horizontal translation. Okay, and remember, when it's inside the parentheses here of x minus something, that negative is built in. Okay, so this is a negative that's already built in, so that's going to be a horizontal translation of 2, and we could say to the right. Okay, 2 to the right. That's a horizontal. This negative is built in. And we've seen that before. And so, excuse me, guys. So here, the purple in our graph here is a parent function. Okay, the purple is the parent function, and the black is the translated, the g of x. So you can tell how it is shifted up 3 and to the right 2. And you can do that here based on where it crosses the x-axis at 1, 1, 0. So if you go up 3 and to the right 2, there's that same spot. That same point is there. Okay. Now, let's keep going. We're not going to graph it because there it is on the right. Okay, so let's go to example 2. Now, if I go to example 2 here, let me go down here and take these off. Because now we're looking at something like this. And I'll just put all these on there. So then we can look and see what we're talking about here in a minute. Okay. Now it says the general form of the exponential function is given by alphabets, and that is a times b of x. So we were dealing with a logarithmic function, and now we're talking about a exponential function, where a, b, and k are real numbers such that b is a positive number not equal to 1. So A says use the properties of exponents to transform the function of g of x as equal to 3 to the 2x plus 1 minus 2 to the general form. And then graph it. What are the values of a, b, and k? Okay. So here we would just have, I don't know why we decided to do that one. Okay. So if we rewrite g of x, we're going to need to rewrite it as a base of 3. Okay. And we have 2x. And then we have 3 to the 1x. And those are multiplied together, right? And then we have minus 2. So let's just rewrite that as, let's do this 3 to the first. That would be 3. Now what's 3 squared? Well, that's 9. So we can do 9x. Okay, so this is here. This is here. And then we can say minus 2. We'll just bring it over. Now we have it in this function, this form right here. Okay. So now that we have it in that form, let's now list all of our points. So A is equal to 3, B is equal to 9, and K is equal to a negative 2. There's our values. Now it says describe the graph of G as a transformation of the graph of 9x. Okay. So if we go look at 9x, see which one that was. That's the black one. Yeah, let's take a look at that. What's going on here? Well, this one's kind of hard to tell. But we're definitely going to have a vertical translation and a stretch, okay, just by looking at it. So let's look at our values and see what they're telling us. That 3 is what? We've got 3 times 9x. Okay. So if this is our original, and this is what we have now, that 3 is going to be our vertical scaling. And that's going to be of a factor of 3. And this is a vertical translation, and that is going to be 2 to the left. And that's what's happening there. Now, excuse me. Now we have described the graph of G as a transformation of an alphabets of 3x. Okay, so let's go back here and scroll down. Actually, might be off. Okay, let's just look at the, let's look at our graph. Or not look at our graph, let's just look at our values. Okay, so if we're looking at a parent function of 3 to the x, what all is happening here? Okay, we would have still going to have a vertical scaling, and we're going to have a vertical translation, and now we're going to end up with that's going to be a horizontal scaling. Okay, so now we have a horizontal scaling here. And what is our vertical scaling? Our vertical scaling is still going to be 3. Our vertical translation is going to still be 2. Oh, so I wrote that wrong on the last one. This should be 2 down. And here, that one should have been 2 down as well, because it's a vertical, not a horizontal. Sorry about that. But now we're also going to have a horizontal scaling. Why do we have a horizontal scaling factor? Well, because now we're going to have to say we're going to have 2x, right? And so that 2 is going to cause it to be that's going to cause it to be a 1/2 scaling factor. Okay. 1/2 scaling factor. Everything else will stay the same though. All right. And I actually think that's what the purple is here. Let me find that again. Where are we on this? That was on 9, wasn't it? No, that's log base 2. No. Oh, here we are. And let's go over here. Well, it doesn't want to let me go that way with it. There it goes. Okay. So yeah, that's actually that one there. Okay. Anyway, let's move on. Now for 1, 2, 3, and 4, we're just going to graph each one and describe the transformations from F to G. Hopefully these will not be too complicated. I find it easier just knowing where they're at in the forms to tell. It's very hard for me to look at a graph and tell what's going on as far as what the scaling factors are. So here we have f of x is a base 3, and then we have 2 log x minus 1. So that's what's going on with that graph. Okay, so we never tell that's probably going to be a horizontal scaling. Don't look like there's going to be a vertical or anything. But let's just look at the factors. Let's see what's going on. So here we have a multiplied by 2. And so that is always key, that's going to be a vertical scaling since it's outside of the parentheses. Vertical scaling is equal to a 2 plus. So we're going to go multiply by 2. But we've got also inside the parentheses here, which is dealing with a horizontal translation. And remember, it's a built-in negative, so it'll be 1 to the right. Okay. So we have a vertical scaling, but a horizontal translation. Yeah, it's shifted 1 to the right. And it's a factor of 2. Stretched by a factor of 2. Okay. Now, let's look at number 2. And if we look at it, it's just base 10. Okay. So when we do this, you may need to write it in a different form. Because it really, if you just look at it, you'd say, well, that doesn't look like anything but a horizontal scaling of 100. But think about what is log 100 plus log of x. Well, that would be 2 plus log of x, right? Log of 100 is 2. So here we're simply going to have a vertical translation of 2 units up. Okay, so rewrite it, and there you have it as a vertical translation of 2 up. And that's it. You can see that pretty clearly there. We just move everything up 2. Okay. Now, let's see here. Got a lot of undefineds here. All right, we're going to have some crazy looking graph here. Let's see what's going on, though, in number 3. Okay. Basic log base 5 parent function. Okay. So I think we could say log 5 plus log 5 x plus 2. And, oh, that's a negative log. And this right here would also be a negative when we separate it. Both of those are going to be negative. Okay, so that's going to be also equal to -1. What to the 5th power is 5. So that's still going to be a -1 minus log of x plus 2, log base 5. All right, so now then we're having to deal with some negatives here. So let's talk about that. Here we're going to have a... All right, let's deal with this 2 right here. That's a horizontal translation. It's a positive 2, which means it's actually a -2. So that'd be 2 to the left. Okay. But let's deal with this negative right here. What does that tell us? That tells us that it's going to be reflected over the x. And then this -1 here is a vertical translation, and it's going to go 1 down, right? Step 1 down. Okay, so you have a horizontal translation of 2 to the left. It's going to reflect over the x-axis because that negative log, and you have a -1, which is a vertical translation down 1 because it's vertical. All right, one more. Let me clear some of this up right quick. And let's look at the graph. I can't really tell a whole lot about the graphs just by looking at them. So, okay, this one doesn't look as crazy at least. All right, so number 4, we're in exponent factor. So let's just break it apart. Excuse me, guys. -2 times 3x, and let's just do times 3 to the -1. Just break apart that exponent there. And let's see what we can do here. Since that's a -1, that means it's going to be in the denominator. So this would actually be 1/3 times 3x times a -2. Let's go ahead and multiply those two together. And so that would be a -2/3 times 3 to the x. And so that is equal to our g of x now. That's another way of writing g to the x. All right, so what does that tell us now? Well, since we have this negative here, that's going to make everything negative. So that exponent still is negative. So we're going to reflect over the x-axis. We know that. Over the x. And then the 2/3 would be a vertical scaling. Since it's multiplied by it. So it's a vertical scaling of 2/3. I think that's it. Okay. And that's what we have there. You can see that 0, 1, as it reflects over the x-axis here, is actually going to be a, -2/3. It's a 2/3 scaling. Okay. That's it.